This lesson is rationalizing the denominator. We're just taking where we started with simplifying radicals and we're carrying it on to the next step. So when it talks about rationalizing the denominator, it's because we started with a fraction. So we had to have a denominator to start with. So we're going to start with the square root of 5/6. So there's some rules that we have to kind of abide by when it comes to fractions inside of radicals. The first one being you can't actually have a fraction inside a radical. So what we want to do, the first thing we want to do is we want to take this fraction and we want to make our life as easy as possible. So we're going to reduce the fraction itself and we're going to rewrite the problem. So I'm going to take this 5/6, and 5/6 actually doesn't reduce. That's as simplified as that got. So we didn't actually get to reduce, but we can rewrite the problem. And when we do that, we're going to try and fake the system. Since we're not allowed to have a fraction inside a radical, what if we said then I'm going to do the square root of 5 over the square root of 6? Well, that's great, except that you can't actually have a denominator that has a radical in it. So we've got to take care of that. So this next thing we're going to do after we've reduced this fraction, which didn't reduce, but we were able to rewrite it, we're going to look for perfect squares. So the second thing we want to do is check for perfect squares. I'm going to put a square there for perfect squares. 5 is not a perfect square. 5 is actually a prime number, so I can't do anything about that. 6 is not a perfect square. If I'm not certain, I can always go back to my calculator and I can check in my calculator. I would rather you check in your calculator and find out that it is or it is not than just skipping that step and then having these really big numbers to deal with at the end of the problem. So 6 is not a perfect square, so we're kind of bummed about that because that would have made our life a lot easier. So we've checked for perfect squares. Now the thing we want to do is we want to multiply by this denominator. So we're going to multiply by the denominator. And I'm going to abbreviate a little bit just for the sake of space. So we're going to take this denominator and we're going to multiply by the denominator. Now the denominator is the square root of 6, so we need to multiply by the square root of 6. And if we multiply by the square root of 6 on the bottom, we multiply by the square root of 6 on the top. Now the nice thing about radicals is that when you're multiplying radicals, all you have to do is keep the radical sign itself and multiply the radicands. So 5 times 6 is 30. And then on the bottom, we've got the square root of 36. Now, we have made a perfect square. We made a perfect square. In the denominator anyway. And that's where we want that to be. We want a perfect square in the denominator. So then we're just going to deal with that. We're going to go back to that lesson on simplifying radicals, and we're going to treat these like two different things. So we've got the square root of 30 on top, and we've got the square root of 36 on the bottom. So I'm going to go right here. I know that this is a perfect square, and that the square root of 36 is 6, because I just multiplied 6's together to make that number. And then I'm going to take this 30, and I'm going to come over here, and I'm going to do an upside down birthday cake. 30 is an even number, so I can divide by 2, which gives me 15. 15 is not even, but it's divisible by 3, which gives me 5. And then 5 is divisible by itself to give me the candle on the bottom. There are no pairs there. If there are no pairs, then there's nothing we can do. It's as simplified as it's going to get. And so we just leave the 30 in the house. So if you were to take your calculator and you were to go into your calculator, and we're going to type in the square root of, I'm going to have to put a fraction in there, 5 over 6, lost my ABC button again, there we go, 5 over 6, we get this odd decimal. So what we should see is if we type in the square root of 30 divided by 6, we should get that same odd decimal. So we're going to do the square root of 30, and then I'm going to arrow out there, and I'm going to divide by 6, and I got the same odd decimal. So these two things have the same value. This is simply the simplified and allowed version of that without a fraction inside the radical, without a radical in the denominator, we've simplified the square root of 5 6. This is not a complicated process. It's just something you have to take the time to do every step. There are no good shortcuts. But if you'll follow these steps, if you'll reduce and rewrite, if you'll check for perfect squares, this will simplify these last two steps. If you skip number 1 and 2, that makes 3 and 4 a lot harder to do because you're going to be dealing with much bigger numbers. So let's run through one more example. Let's do the square root of 6 over 15. So we're going to go back to our steps over here. We want to reduce and rewrite it. If you're not comfortable reducing fractions, you can do that in your calculator. If you have a graphing calculator, use the alpha y equals if you're using a TI-83. This is what I have today, so this is what we're using. So 6 over 15 reduces to 2/5. So I've reduced my fraction to 2/5. 5 is way smaller than 15. I'm going to be much happier with that number when we get there. And I'm also going to rewrite it as two radicals, one on top of the other one. So I'm going to write the square root of 2 over the square root of 5. So I've reduced the fraction. I've rewritten the fraction into two radicals. Now I'm going to check for perfect squares. 2 is not a perfect square. 5 is not a perfect square. They're actually both prime numbers. So the next thing I want to do is I want to multiply that by that denominator. So I'm going to take that square root of 5, and I'm going to say the square root of 5 divided by, or multiplied times the square root of 5, the square root of 2 multiplied times the square root of 5. So we keep the radical. 2 times 5 is 10. That's what we have on the top. On the bottom, we keep the radical, and 5 times 5 is 25. We made a perfect square. It is a perfect square. That's what we want because we want to get rid of the radical sign on the bottom of our fraction. So we could go over here and we could do the birthday cake of 10, but I'm just going to tell you, we just multiplied 2 and 5 together to get 10. Those are the prime factors that make 10. 10 does not simplify. So we've got the square root of 10 over the square root of 25, which is 5. Not complicated at all if we will follow the steps. The key is following the steps. That's the thing about algebra. If you don't follow the steps, things can go haywire really fast. Let's do one more example and see if maybe we can get lucky and find something that actually has a perfect square in it. So let's do 24 over 27, and we want to know the square root of that entire thing. So we'll go back to our steps up here at the top of our paper. We're going to reduce and we're going to rewrite the fraction. So 24 over 27, 24 over 27 is 8/9. So I've reduced the fraction. I would much rather deal with a 9 than I would a 27 when I start having to multiply by that denominator. So I've reduced the fraction to 8 over 9, and I'm going to rewrite it as the square root of 8 over the square root of 9. Now, here's a problem where it's going to be really important that you go ahead and check for perfect squares. 8's not a perfect square. You can type it in your calculator all day long. 8's not going to be a perfect square. But 9 is a perfect square. Well, if I know that the square root of 9 is 3, did the radical that was on the bottom of my fraction disappear? Yes, it did. So now all I have on top is the square root of 8, and all I need to do is simplify, see if I can simplify the square root of 8, even though I know it's not a perfect square. I can probably do a birthday cake and simplify that one down a little bit. So let's do that. So 8 divided by 2 is 4. 4 can be divided by 2, and 4 divided by 2 is 2. So we get a 2, and we end up with a 1 on the bottom of our birthday cake. There's our pair. We got a pair of 2's. So 2 goes outside because the pair went outside. This 2 had no friends, so he stayed inside. And then this 3 is our denominator. Doesn't have a radical symbol. It's already simplified. So the square root of 27, or 24 over 27, simplifies to 2 square root of 2 over 3. You want to check those things. It seems really easy to just automatically start multiplying by the denominator and then doing all of your birthday cakes and trying to simplify. But if you will reduce that fraction and get those numbers a little bit smaller, if you'll check for perfect squares, sometimes you get lucky and there's a perfect square there and it takes care of itself. You don't have to multiply by it to force a perfect square to happen. It's there, and it saves you a step in the process. Something else that you want to be able to recognize is when you get to this final step, sometimes this isn't the final step. Sometimes we end up with fractions like, I'm going to make one up real quick here instead of making you solve out an entire problem. If we end up with 6 square root of 2 over 12, this can actually be simplified even further. You can simplify or reduce, I like the word reduce, let's try that. Reduce the outside fraction. What do I mean by outside fraction? I mean the numbers that are outside the radical. So I have a 6 and a 12 here. That's my outside fraction. So 6 over 12 will reduce. 6 will go into itself one time. We can't touch the square root of 2. It has to stay there. And 6 will go into 12 twice. So this outside fraction would reduce to 1/2. Like I said, can't touch what's in the house. It can't be touched. It's inside. You can't do anything with it. But we can reduce the outside fraction. You might see it written like this with a 1 outside. More than likely, you would just see it written as the square root of 2 over 2. These two things have the same value. This one is the reduced fraction of this one. So check for reduced fractions. Check for perfect squares before you start multiplying things and creating these big numbers that are hard to deal with. Rationalizing the denominator is a simple process if you will follow the steps. So let's write that in our summary. Follow the steps. Follow the steps. Always reduce. Know your perfect squares. Just like things I want you to have in your head that you always do. Know perfect squares. Check things in your calculator. All of this is work that you know how to do. It's taking concepts that you already understand, like prime numbers and multiplying and dividing, and using them in a new way. It's not anything that you can't conquer.